What if I told you that we've already found the technology to build a computer? But it's not just any normal computer. This is a quantum computer, and we're able to do so by manipulating the qubits, which are located inside of the quantum computer. In fact, we are at the development stages of using quantum mechanics to enhance technology, making it more powerful. It's just a matter of fact that we have to incorporate the madness and uncertainty of quantum mechanics into the computer. Take a look at this image, EGNAC. It's one of the first computers which was invented half a century ago, which almost took 2 years to complete, and it's only able to carry out simple commands. Now take a look at this laptop I'm holding now. See the difference? It has a quicker CPU, and it's a really small CPU also. And also, the size of the computer has changed dramatically. And well, look at this computer right here. It's too big to be carried around anywhere, while this computer right here, I could just carry it wherever I want. What if I want a computer which is even smaller, but a more powerful CPU? Well, it's doable, but because of the computer size, the CPU also have to shrink, which would make the CPU less powerful. What if I even want a smaller computer and a more powerful CPU? Well, the thing is, you really can't. And there's a reason behind it. As the computer gets smaller and smaller, the components inside the computer also need to shrink. However, the bits which are flowing through the transistors would just soon be able to transfer themselves to the other side of the transistor. This phenomenon is called quantum tunneling, which in this case is not a good situation because transistors are not able to stop bits passing through, and the computer will not be able to function at all. Just like putting a bunch of young children in a classroom without a teacher. You could probably imagine what would happen to them. Have you ever thought of putting a cat in a box and a tube of poison which has 50% chance of not breaking and 50% chance that would break? Well, Aaron Schrodinger has also written a thought experiment about this too. Before opening the box, you would not know if the cat is dead or alive. So, we would assume that the cat is alive and dead at the same time. This theory sounded very unrealistic, but if you are analyzing the behavior of particles at a subatomic level, you would soon realize that particles do not behave like we think they should. Schrödinger's cat has described one of the most fundamental theories of subatomic particles, which is superposition. Superposition has described the quantum phenomenon which allows atoms to be in two states at the same time. With that being said, that means that bits, which are small units of data, can be a 0 and a 1 at the same time, instead of just being either a 0 or a 1. We call these bits, which are in the superposition of two states, quantum bits, which are more commonly known as qubits. But how is this going to help in quantum computing and make calculation faster? Well, think about it. If you have one single qubit, you'll be able to do two calculations at the same time. If you have two, then you'll be able to do 2 to the power of 2 calculations at the same time. If you have 3, you have 8. So, if I have 10 qubits, I'd be able to do 1,024 calculations at the same time, which is pretty fast. And this enables us to calculate problems in a very short amount of time. And that is the difference between computers and quantum computers. To enable qubits to function as quickly as possible, we would need to put qubits in an environment where there's no electrical resistance at all. Superconducting computer chips allows electricity to flow through at a very low temperature. Scientists use cryocoolers to cool the quantum chip to a very, very low temperature, which is essentially around 10 to 15 millikelvin, which also equates to around negative 257 degrees Celsius. The place where it houses quantum computers also needs to be dust-free, as dust, when compared to qubits, could be giant substances, and if they interact with qubits, it would cause the qubits to decohere and loses its quantum state. This also takes a lot of energy and space to create this superconducting state. So the lab that houses these quantum computers needs to be a dust-free large space. Even if we're able to obtain a large space which is dust-free, we still cannot get through the obstacle which is called quantum decoherence. This phenomenon happens when substances in a quantum state interact with classical objects and loses its quantum behavior. Quantum decoherence could cause hours and hours of hard work to be lost due to its environment, and scientists would have to start all over again. With quantum computers being able to run complex calculations in a matter of seconds, there's so much potential for quantum computers. For example, cryptography allows a certain algorithm to be solved using a quantum computer, which normally would only needs to be solved by a cryptographer with a huge amount of time. Cryptography allows complex security systems to be made, therefore being able to code online security systems and make it more secure and safe for us to shop online during Black Friday sales. But the potential that many tech companies are looking for, is quantum supremacy. Quantum supremacy is a process in which quantum computers are able to solve algorithms that classical computers couldn't solve. This is obviously a big deal, as having a quantum computer that could do calculations that today's computer can't, and even potentially finding algorithms even quicker than humans. Around early 2017, Google has announced that they've created a 72-qubit quantum chip, which they thought it was enough to surpass quantum supremacy. However, it wasn't, so they have to keep going and adding more and more qubits into the quantum computer chip. However, there's a risk to that. The more qubits that are added into a computer chip, the more errors would occur. But have we actually built a quantum computer which could replace classical computers? Not quite yet, but I believe that quantum computers have so much potential in overtaking classical computers. We've reached a point in history that we've come across yet another great challenge, which is once we have the answer, we'll be able to achieve many great things. Just like NASA competing in the arms race with Soviet Union, which then leading NASA building a computer and enabling calculations for trajectories to be done faster. However, this time we're competing against ourselves, in which one day we hope to achieve quantum supremacy, allowing more new technologies to be invented and hopefully give us answers and even more bizarre questions about quantum world. Thank you. Which then leading them to creating a